My name is Christoph Edeler. I'm lead application engineer at Ansys, and this is the second lesson of 5 lessons of this course regarding SCADE motor control. In this lesson, we will focus on the software integration aspect. In the first lesson, I introduced the little system controlling a motor and implementing some software functionalities into a little target. And this lesson is then indeed about the overall software integration. Here we have an overview. First of all, we have the so-called target environment, which means this is a piece of software which contains the target compiler. So the compiler which generates a final binary for the target out of the sources which are provided by SCADE. By the way, these are C sources, so the programming language C. So SCADE will produce C sources, and our target environment will take these C sources and integrate them into a final binary which can be flashed on the target. For the integration, there is an IDE. As we have a target from Microchip, we will also take the Microchip Studio as our integration IDE. I will quickly go through the integration project settings. And last but not least, we will have a look at SCADE, at some project settings, the build process, and what do we need to adapt to the environment here. So as an overview, it's important to understand that the SCADE model is responsible for all the control and monitoring features we have here. That means there is a little code for, let's say, initializing the hardware in the first step. And then this initialization code, which is handwritten, will kind of switch over to SCADE. And the SCADE part will be cyclically called during runtime. That means all the important features and all the functionally critical parts are all implemented in SCADE. The root operator, as we call it in SCADE, that is the entry point. So that entry point for the cyclic control function. And as I said, all the critical functions are developed in SCADE. SCADE will use its code generator. It's called KCG, and this KCG will transform the SCADE model into C sources, and those are then the heart of the integration project. Why do we need this integration project? SCADE is quite well abstracted from any hardware aspects. So for basic hardware initializations, hardware, let's say, interrupt handling, basic port initializations, things like that. So all the things of stuff which does a hardware abstraction layer, this needs to be outside of SCADE. And that's why we have here one C file for the basic hardware initialization and the basic timing to call here the SCADE root operator. This integration project just needs a one-time setup in the beginning, and once everything is set up, you can continue your development in SCADE only, which is very comfortable, and you can really focus on all the advantages of using SCADE here. This graphical overview shows the integration project. This is the large box here. This is implemented in Microchip Studio. As mentioned before, the main task is here to call the SCADE entry point operator in a cyclic manner. Beside that, I introduced a compiler switch here that allows to select between different control options. We will come to that in the next lesson, but it's eases to compare and switch between different implementation environments, between different control approaches, etc. Yeah, as I said, the hardware initialization is done here. The interrupt control initialization is done here. And in this example, also the PWM signal generation for driving the motor is done here, as well as the analog input measurement. All of these things are quite timing critical. That's why I decided to do them here. And in the end, it's abstracting all the hardware stuff, as I said, and SCADE will just see, let's say, a set value and a current value, which is given from the hardware. That means the current value would be the current measured speed of the motor, and the set value would be the target speed coming from the potentiometer. And the control value here would be the direct input from SCADE to the pulse width modulation signal. Inside SCADE, we are now in this inner SCADE block here. It is again subdivided into a control logic and into the monitoring features. I will get to that later again. We are here just in the integration world. And last but not least, in addition to the SCADE sources, we have only here one C file, integration.c and integration.h. So one C file, one header file to do all this integration stuff. The Microchip Studio IDE looks like this. So quite similar to Visual Studio, for instance. It's basically, it's the same engine behind. And yeah, just to give you a feeling for that. So we see here the integration.c file, which is in the editor, and on the right-hand side is all the list of files which are referenced. It looks like very many files, but it's just a drag and drop here from the SCADE folder here. So it's not a problem at all. The only thing which is really important is here this integration.c. And this one will reference to the integration.h. So these are the most important points here. And then somewhere in behind the scenes here, we need to set two settings, one for the target speed. This is just required from this environment. I selected to set the optimization to -OS for size optimization. This is also an important parameter if it goes down to runtime optimization, etc. So I was not selecting speed optimization, I was indeed selecting size optimization. It works quite well, so I did not put too much effort into this. But yeah, that's basically all you need to know. And if you press here the dedicated button for build and flash, then it will take all the C sources, build the binary and flash it to the target. Okay, here we have now switched to the SCADE application. So we are now here in the SCADE IDE, and we also need to have some settings here. First of all, we have to define our root operator. This is again the entry point. The integration part will call, and this just needs to be specified here in the settings for the code generator. I selected to have the code generator 662, and the other settings are defaults here, so it's not very much you have to change. And then once you hit the generate button here in the IDE of SCADE, then it will generate all the source files you've seen before. So for instance, of course, this root operator C file, which is here this control SCADE.c, but also all the list of files you have seen as well. For instance, the emergency stop.c functionality, and so on and so forth. It's a list of, I don't know, 30 or 40 files, including the header files. And that's, yeah, that's what's listed in the Microchip IDE in the end. Okay. Yeah, and the build process is pretty straightforward then. We need 2 additional files from the SCADE world to work well with the integration. The KCG assign and the user macros. The user macros, for instance, are telling SCADE how the SCADE types, data types map to the target data types. So there is a KCG bool, for instance, and the Microchip IDE will provide kind of a standard bool. And to map this KCG bool and the bool, this is done in the user macros. Yeah, once we have all the SCADE sources, so once we triggered the KCG code generator, we will have all the C and H sources. Those are compiled with Microchip Studio again to, in the first step, have the object files. Then it will be linked and built together to the binary, to the L file and some other files. And for instance, the .hex file, that one can be flashed to our target. So in the end, it's one click in SCADE to build all these sources, and it's another one click in the Microchip Studio to build and flash in all-in-ones. So it's very, very simple. Yeah, here again, some explanation what these additional 2 files are all about. The user macros, again, is for the mapping of the types. I explained that. And as a little helper, I programmed a little batch file which copies the files from here to there. That's very comfortable in the end. What could be improved? I said right now it's a 2-click workflow, but you could even reduce it to a 1-click workflow. One could trigger the generation of C code in SCADE. You could trigger it from Microchip Studio as a pre-compile event, I think, I remember. So you would remote control kind of the SCADE code generator, but I skipped that because it's not a big project, so it doesn't hurt a lot to have 2 clicks here. Same for the copying of this KCG assign and user macro files. There is the danger that they could be overwritten. So I created this little batch file to copy them, but you could also call this batch file as a precompile event. But again, this is for future optimization. This is not really necessary right now. And just to give you a feeling for it, here again, the SCADE IDE. On the left-hand side, we have here the tree with all the model-based elements, and I would like to put a focus here on the control SCADE operator, which is indeed our root operator, our cyclically called functionality. And this one exhibits a diagram here, control SCADE, and what's in this diagram, so what is the logic of this operator, this is shown here. A little architecture on the top side here, and some control operation P or PI on the lower side here. We will get to that later. Okay, so this was a little journey through the software integration. Thanks for listening, and I hope I will see you in lesson 3. Thank you very much.